Hello everyone! Welcome back to the Algebra 1 series. Today we're going to talk about rational numbers on a number line. Rational. What does that mean? Well, sometimes we talk about, if we're gossiping, there's some people out there are rational, some people are irrational. So it probably gives you a little bit of an idea going into this lesson what it is. But we'll get more into the definition a little later. We have two goals today. One is to graph rational numbers on a number line. And number two, we want to find absolute values of rational numbers. Okay? So let's go ahead and draw a number line. Okay, so this is a number line. And if you want to know what is a negative number, it will be all the numbers -1 or less. So these are negative numbers. And if you're looking for positive numbers, anybody like positivity in their life? You can look at a positive number. All right, so these are number 1 and above to the right. Okay, what is a whole number? Well, that's these numbers 0 and above. Okay, what are natural numbers? Natural numbers are numbers 1 and above. And what are integers? Integers. Well, that's any one of these whole numbers here, or natural numbers that could be positive or negative. It can even be 0. These are integers. All right, so let's look at a number on the number line. Let's find -2. Where is -2? We know that it should be left of the 0 because it is negative. It is a negative number. There it is. So what we're going to do is put a dot here. Okay? And what does that dot mean? Well, this is a coordinate then. Or as my British friends would say, coordinate. This is a coordinate. Okay, let's look at a definition. Rational number. What is a rational number? It is any number that can be written in the form A over B, where, ooh, that was a terrible looking B. Let's try that again. Where A and B are integers and B is not equal to 0. So basically the denominator cannot be 0. If the denominator is 0, this becomes what we call infinity. Now we don't want to really worry about that right now at this stage in time, but for future knowledge, that's what it is. So let's look at some examples of some rational numbers. Remember, they are not irrational, they are rational. So we got 1 over 7. So B is not equal to 0. And all these numbers are integers. 1 and 7 are integers. All right, let's look at minus 3 over 12. Is minus 3 an integer? Yes. Is b an integer? 12, is that an integer? Yes. And 12 is not equal to 0. We can even have improper fractions. If I can draw numbers. 40 over 3. 40 and 3 are both integers, and 3 is not 0. So this passes the check as well. Let's try this number, 0.1. What do you think about this number? What about 0.3? But the 3 is repeating. What about 4.6767 and ... So the 6 and the 7 continue to repeat. I'll let you guys think about that, and you can provide me some answers in the comments. Okay? All right. Let's look at another definition here, coordinate, or as British say, coordinate. So this is the number that corresponds to a point on a number line. So remember, we did that earlier. We were looking for -2 up here on the number line, and we put a dot there at number 2, and that is a coordinate. All right, let's look at some example here. All right. So we're going to have a set of numbers, and we want to graph them on the number line. So our first set is -3, -1, 0, 1, 3, and 5. So let's draw a number line. And let's put 0 here. 1, 2, 3, 4, 5, -1, -2, -3, -4, -5. All right. Let's find -3. That is here. So we need to put a dot there. Let's find -1. Here we need to put a dot there. 0. We put a dot there. 1. We put a dot there. 3. We put a dot there. And 5. We put a dot there. All right, let's look at another number set. Let's say we have -1/3. 0, 1/3, and 2/3. All right, let's graph this. All right, so let's put 0 here. And here we have 1/3, 2/3, 1, 4/3, 5/3. So here we have -1/3, -2/3, -1, -4/3. Okay, where is -1/3? It should be left of the 0 because it is negative. Where is 0? Well, it's usually somewhere near the middle, and here we found it. And then +1/3 should be right of 0, and here we found that. And then +2/3, that's to the right of that, it's greater than 1/3. Great job. Let's look at another one. We want to do integers less than -2 or greater than, if I can spell greater, greater than or equal to 5. Alright, so let's draw a number line. And let's put 0 here. 1, 2, 3, 4, 5, 6. -1, -2, -3, -4, -5. Alright, so what we're doing, first of all, we have an OR statement here, right? So we have to do this or this. So what's the first statement here? We're looking for integers less than -2. Alright. So less than -2. So it does not include -2 because it doesn't say less than or equal to -2. It has to be less than number 2, -2. So we got -3, -4, and -5. Now we're looking for greater than or equal to 5. So to be greater than, it has to be to the right of 5. So we got 6. Okay. All right. Let's look at another definition. Absolute value. This is the distance from 0 on a number line. Okay, so let's look at an example here. We want to find the absolute value, and how do we do that? Well, we add these two vertical bars, one on either side of the number. And what these mean, these two bars, means that you're doing the absolute value. If I can spell. Okay. Alright, so what would this equal? On the number line, I don't think we have one as far as -7 here, but if we did, it would be 7 away from 0, because like -1 is 1 from 0, -2 is 2 from 0, 3 positive is 3 from 0, 4 positive is 4 from 0, so the answer here would be 7. Alright, let's look at another one. What is absolute value of -3 over 7? Well, it would be 3/7 from 0. Okay, so let's evaluate in another example. 40 minus x plus 12 if, we don't want to make that look like a parentheses, straight bars, if x equals to 7. So we saw here, we basically removed the negative sign to make this value equal this value, right? Well, what do we do if the value is positive? In this case, we have a positive 7. Alright, so we solve this. 40, and we're going to use the substitution rule. X is 7, 7 plus 12. Alright, so we solve within the absolute symbol here. 40 minus 19, absolute value of 19. Alright, what's the absolute value of 19? It just remains itself. If it's already positive, it's like looking in the mirror. So when you do the absolute value of a positive number, it's just itself. So 40 minus 19, and that equals 21. Great job. Alright, so let's look at a problem here. So we want to look at the same day low temperatures for certain cities. Alright, so what are these cities? And what are these temperatures? We're going to look at a pretty cold place here. Let's look at Calgary, Edmonton, and Toronto. And we'll say on the same day, the low temperatures were negative 40 degrees Fahrenheit, brr, negative 55 degrees Fahrenheit, brr, 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 and negative 20 degrees Fahrenheit, brr. Okay, these are some cold temperatures. So what do we want to do? We want to draw a number line that represents the data. Okay, so let's draw a number line. Oh, let's do this a little differently. We're doing negative temperatures, so we won't put 0 on the right because the negative temperatures are on the left. All right. So I'm trying to draw these about equal here. Oh, 50. We need a little bit longer, right? Oh, we lost our line. We'll draw that back. All right, so we need to find Calgary's temperature, negative 40 degrees Fahrenheit. So that is right here. So we need to put a dot there. Then Edmonton's negative 55. Ooh, that's cold. And then Toronto, we got negative 20. All right. So some pretty chilly temperatures for this day. I don't know how accurate these numbers are, these temperatures, but these are some chilly numbers or temperatures. All right, now, what do we want to do with this information? We want to write the absolute value of each temperature. All right, so let's start here and we'll do this one next and then this one. So negative 55 degree Fahrenheit. So we just basically, if you remember, we remove the negative. So this is minus 55 degree Fahrenheit. All right, let's look at the next one, negative 40 degree Fahrenheit. So this would become, I made a mistake, that'd be 55 degree Fahrenheit. This would become 40 degree Fahrenheit. And then the last one is negative 20 degree Fahrenheit. And so this becomes 20 degree Fahrenheit. Much warmer temperature. Positive 55 is much warmer than negative 55. I'm sure you can tell the difference if you've experienced them. All right, so that's it for rational numbers on a number line. I hope you learned something today, and if you have any questions or comments, you can put them in the comment field. If you like this, like the video, please, and please subscribe. This is MultiPro. I will see you in the next lesson.